Hey guys, so today we are on the last part of our chapter. We are going to look at numericals for conservation of momentum, or the third law of motion, right? So I've taken an example problem from your reader itself. It's on page number 47. If it's in different textbook, old or new, just check. It'll be at the last part of the chapter. Okay, now I'll read it out for you. Cannon of mass some kg located on a horizontal platform fires a shell of mass some 300 kg in horizontal direction with velocity 400 meters per second. Find the velocity of cannon after shooting. Okay, so it looks a little lengthy, but the sum is quite simple. All right. Now what I'm going to do is I'm going to give you a slightly visual example of what these types of sums can be, right? So if you see, it's about a cannon. If you know what a cannon is, it's basically a gun. All right. What I'm going to do, I'm going to show it to you with the help of this little toy gun, right? So if you remember, in our formula for conservation of momentum, it kind of went like this. I'll write it down over here on the side. m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2, right? So m is nothing but mass, u and v are velocity. U is first velocity, initial velocity, v is final velocity. Okay, so I just write that down also. M mass, u is initial velocity or speed, and v is final velocity or speed, same thing. Okay, now we need to figure out what are all these things, but before that, let's try to figure out how this gun works, right? Right now, if you see, my gun is not moving, it's at rest, right? Neither is the bullet that is, or the shell or whatever is that is inside the gun, right? So now none of the, not the bullet, not the gun, nothing is moving. But the moment I fire it, the bullet flies off, and when the bullet flies, it pushes the gun back a little bit. Okay, it's called as recoil. Why that happens is because of momentum, law of conservation of momentum. Okay. Initially, remember, the gun is not moving, the bullet is also not moving. So we need to talk about initial velocity before firing. Okay, and after firing comes the final velocity. That is what it's trying to tell us. Now, so before firing, if you see, if none of them are moving, can I say initial velocity is 0, right? Because they are not moving, no speed, right? So 0. So that's the first thing I will write. Initial velocity is 0 for both the objects, object 1 and object 2. All right. Over here, cannon is nothing but tope. You know what tope is? Like you have this big ball kind of thing that you fire, right? Now, cannon is there, mass for cannon is given, m1 is given. Okay, so I'll write m1 beside u1 itself. m1 is nothing but 12,000 kilogram. It's a big weapon, it's heavy, right? So this 12,000 kilogram weapon, initially it's not moving. Located on platform, fires a shell of mass 300 kilogram. Now m2 is also given. Okay, so shell, because cannons have a big heavy ball, no? So we call it a shell and it's like heavy, so it's 300 kilogram. Even that shell is not moving first, right, when it's inside the cannon. But when you fire it, because of some force inside with the gunpowder or whatever chemical reaction that happens, it just flies off, right? So that force is inside of these two objects. That is why the shell flies with a velocity v2, 400 meters per second. Okay, so I now have v2 also with me. Okay, v2 is nothing but 400 meters per second. So that shell is flying with 400 meters per second. Find velocity of cannon after shooting, meaning what is v1. Okay, like I said, you will face some recoil every time you shoot, right? Same with the cannon also, will push a little back. What is that speed with which it gets pushed back is what he is asking us. That is all, as simple as that. Okay, we have all the values. The only matter is to substitute it in that formula. Okay, now m1 u1 plus m2, or I'll write it the way we got it in the derivation, right? We got it m1 v1 plus m2 v2 equals to m1 u1 plus m2 u2. Even if you write this here and that there, it doesn't matter, it's fine. Okay, since it's equals to, it is okay. Now I'll simply substitute. Okay, m1, what is m1? 12,000 into, what is v1? We don't know, I'll leave it as v1, plus m2, what is m2? 300 into v2. So if there's nothing, it means into. Okay, v2 is 400, 300 into 400 equals to again m1, so that is 12,000 into u1, which is 0, plus m2, which is 300 into 0. Now keep in mind, we are multiplying both these things with 0, right? So that means it is first let me calculate here, 12,000 into v1, leave it like that, plus 300 into 400. How much is 300 into 400? 3 4s are 12, 1 2 3 4. Okay, equals to 12,000 into 0 is nothing but 0. 300 into 0 is also 0. 0 plus 0 is also 0. Right, so I can say 12,000 into V1 plus 1,20,000 equals to 0. Right, now I need to find V1. So this is one term, this is second term. Second term I'll take to right side. 12,000 into V1 equals to minus 1,20,000. Okay, now I need to find v1. This is multiplied, so if I take it to other side, it becomes division, right? So v1 equals to minus 1,20,000 divided by 12,000. Okay, so 12,000 into 10 gives me this, right? So I will simply write it as 12,000 into 10, right? One extra zero remains, so minus is there and 10 is remaining, so I will say v1 equals to minus 10, right? Since it's velocity, the unit has to be velocity, meters per second. Okay, now what is this minus? It's not there in this velocity, but it's there in this velocity, right? What that minus tells us is it's in opposite direction of this velocity, meaning if the shell fires forward, the cannon pushes backward. Okay, it's going in the opposite direction, that is why minus is coming. And 10 meters per second, so if this is flying with 400 meters per second forward, the bullet, then the cannon flies back with 10 meters per second back, because it is minus. As simple as that. Okay, so every time you get a question like this with guns shooting, it usually means the initial velocity is 0. Okay, before shooting nothing is moving, so keep that thing in mind. Alright, it's a very simple sum, you just need to use the same formula wherever this type of question is there. Alright, okay, so that's it for now. Tomorrow the next class you'll be having an end of your chapter test. Okay, I'll see you in the next one.